Hello, I'm ZB. I'm going to tell you a bit about my NPM package. It's generally going to be about supply chain security. You've probably heard a bunch about it already. I'm hoping to show you something new about it. So let's get into it. Well, first of all, what do you do for a living? I install NPM packages most of the time. You should try it sometime. It's fun. And let's give it a second and appreciate how many NPM packages we're installing day to day. And when you do, you should be aware of the pesky hackers that roam around, and they can produce malicious packages or use vulnerabilities in existing packages. There's generally stuff that you need to be aware of. And you've probably heard about some of the most recent malicious packages going on. Some of them maliciously changed by the authors, some of them taken over by someone with bad intentions. By the way, socket.dev can help you figure that out if you're checking your package. But that shout out aside, are you looking into your packages? There's a lot of stuff inside. Let's look inside. Would you notice if anything was unusual about a package, if there was something wrong with a package you're installing or updating? Well, honestly, barely anyone really looks into their packages. And even if they do, they look at their direct dependencies. Right? What about indirect dependencies? There's tools, but there's a lot of stuff in your dependencies that could potentially turn malicious when someone steals their password or gets in a bad mood. So what do we do now? Well, there's tools to handle vulnerable packages. I've been talking about NPM audit and what you can do about it for a few years now. You can even look at the previous talk on this exact conference that I gave, which was about vulnerabilities in packages. So I've been on the receiving end of a malicious package before, and I started wondering what would it be like to be on the publishing end of a malicious package. So let's try that. I published a package. You're not going to like it. Well, I'm going to figure out a way to get my package into your dependencies. I'm going to sneak it in as a dependency of a dependency of a dependency of a dependency of a dependency that you've installed. Maybe by convincing someone to accept it as their dependency or hacking into their account. I don't know. We'll figure something out. Okay, you might be thinking, well, if it's a package that I just introduced somewhere deep in your dependencies that you don't even know exists, would you ever run it? If your dependency is not even using it and you're not using it directly, would you run any of my code? Well, yes, you would. So we have lifecycle operations. So if you npm install or you npm CI or you yarn install, all of these are running post-install scripts for every package that has them. So I could put something malicious in the script that modifies anything around or hacks you directly, and you would run it. What now? Yeah, that's bad. And that's why the malicious packages we've heard about were an issue. People are running someone else's code. And most of the attacks you've heard to date were attacks based on the post-install scripts. Yeah, you want to see a demo? Let me show you a demo. OK, now this is a package.json of a newly generated Next.js application. If you don't know what Next.js is, you should check it out. It's really great. So this is a clean Next.js application. I can start it up. The only thing I did was install my malicious package here. So I can start the application. It's going to be npm. Let's do the dev. It's starting the application, localhost 3000. Yeah, let's go there. Spinning up. Yeah, it's compiled. OK. So this is a clean Next.js application that you get from the generator. Now, it's running here, and I should have run it in the background. OK, let's open a new terminal. OK, now I do a clean installation or just add my malicious package. So yarn add this one. Whenever this action runs, my package is being downloaded and installed, and it's doing things. Let's ignore this. This is for another demo, but check it out. The editor is showing that there's changes to the application. So hello, this is the same application, but now with additional content. I just installed a package, and that package was able to go up outside of the node modules and modify my application by just knowing a bit of context that this is a Next.js app. It was able to introduce this. Could have been something worse. Yeah, not fun, not fun. OK. Thank you, Next.js application. Let's turn you off and go back here. So that was just the first demo to show you that things can happen. OK, so now you're thinking, I can defend from that by not running npm installations where my application is and not taking the changes they introduce with me. So this is what I did for many years. Spin up a new container, run npm CI, copy node modules to some storage, and destroy the container. So if a malicious script tried to mess with etc hosts or anything in the system no longer exists. If it messed with my application copy that was there no longer exists. I just took node modules, right? Fine, yes, OK. There's a lot I can do with these assumptions. So let's take a look at some more examples. I'm holding up the slide so we can take a screenshot of the conference going on with the slide saying "Hold my beer." But yeah, I'm going to show you stuff now. OK, thank you, Next.js application. We're going to look at an example of a pipeline now. So here, what do we have here? There's a simple package. So we're now authoring a package. You're working for a company that has an SDK or something, and it's published to NPM. And you generally want to avoid infecting people with ugly stuff when they're using your tool, right? You have a package JSON with some basic configuration and stuff. And you have a pipeline. I didn't set up the whole pipeline here because looking at the pipeline spinning up and analyzing the details would just be boring for you. But I have a simulation of a pipeline where I simulated with a script here. So this is a cleanup. I run npm CI. Then I run some building or whatever. And then I take the dist folder and the package JSON, and I put it in the clean publish environment where the application can be published, right? Because what you need is the build code of your npm package that you want to put out, and you need a README and a package JSON that get published. OK, fine. So we're caching that and destroying the whole system in case a malicious package modified something, right? And then here is what the publish looks like. We go into the clean environment. Let's assume this is like a clean container in which you run this step. And this is the only place where this NPM token variable exists in the context, in the environment in which you're running. We put that in NPM settings, do the release and publish. Okay, fine. Let's run both of those scripts. Okay, so first, I'm going to run the build. Where am I? Wrong app. Yes, wrong app. Okay. Oh, yeah, thanks for the reminder. So this is me, the hacker, with a server listening on a port waiting for stuff to happen. Okay, spoiler alert, stuff is going to happen. Okay, example, pipeline. Hello, pipeline. Now let's run my bash script simulating the build. Here we're installing and building and everything. Okay, fine, this is done. The clean publish environment now has everything inside of it. Oh, I think I should have removed the node modules before running this, but maybe not. Yeah, maybe not. Okay, so this is what we're now publishing. Let's bash another script. Pipeline simulation publish. Okay, boom. And this is now visible, so we can already see what's happening. Let's switch to my hacker server. Here we got a GET request with the secret that was supposed to be safely encapsulated in an environment for running publishing. How did that happen? So the only thing that we copied after my evil script run was the stuff that we're publishing and the dist. We don't even have in the clean publish, and we don't even have the node modules. We didn't run any of the code from the dist folder. How did I steal the NPM token? It's on screen. It's here. So my evil package, when installed, modified your package.json to add a pre-publish only script that only runs whenever you publish the package to the registry, and it's using curl to send your NPM token environment variable to my server. Done. And so all you needed to do is to cache the package.json instead of taking a clean one from your repository. And that was the only mistake here. Everything else was pretty much secure. Okay, so that's demo number 1, but it gets worse. Let's take a look at another application. Yeah, I can stop that now. And I can go here. So there's an example app. This is a brand new TypeScript project. So as you can see, it has one script that's compiling app.ts. We've got TypeScript installed, and somewhere in the dependencies, we have my malicious package. So there's app.ts. It's a TypeScript application. It compiles. What do you want? Perfectly valid TypeScript with my tsconfig JSON configuration. There's hundreds of different TypeScripts you can configure, really. So yeah, this is deliberately a very simple app so that you can see there's nothing going on. Right, and there's a package JSON, and now all I need to do is npm ci, right, to reinstall everything. Okay, thank you. Did anything change? As you can see, the editor is not pointing out any changes. So package JSON, clean, not changed. Package lock, irrelevant. tsconfig didn't change. App.ts didn't change. Okay, We're safe. We're safe. We're good. Time to build and deploy our application. NPM start is running tsc app.ts. Nothing else runs. As you can see, everything is set up here so that if another script runs, it would be visible. It's not. We've produced app.js. It's time to upload it to our servers. But first, let's do something no one does and take a look at the compiled TypeScript. Oh, I don't remember putting it there. What's this? So just a quick look at what's here. In a try-catch statement, in case we're not in Node, is a gift for Node.js applications where I take process.env with potential secrets, access tokens, and I put that in a temporary file, but I could as well send it to my evil server that you saw before. Right? In case we're modifying a code that ends up in the browser, I have this. This is the shortest reflected cross-site scripting plug that I can do. So if I get the URL to an application that has this code somewhere that it runs, and I put some JavaScript in the hash segment of the URL, give that URL to someone. When they click on it and they're logged into the application, they're going to run my JavaScript as them in that application. This is a fairly simple vulnerability. And I'm announcing my presence also. OK, fun. How did that happen? Well, let me tell you. But first, some background. I was into JavaScript security before I knew any JavaScript or security. This is literally the first JavaScript I've ever written. These 5 lines would break the Explorer process to a point where not only Internet Explorer is broken, but it crashes the whole Explorer.exe, which is rendering your desktop and Windows and everything. That happened in Windows 98 and in XP until they fixed it in Service Pack 2, where this would only crash the entire browser. OK, so with that, I think this is a classic security presentation now. You've seen a vulnerability that's no longer there because someone fixed it. Very nice. OK, back to the TypeScript compiler. Did I hack the TypeScript compiler? Not really. So what I did was I spent 2 evenings figuring out how to modify the compiled JS file of the TypeScript compiler that comes to you when you install it in your Node modules, so that whenever it generates files, it's going to inject a malicious snippet into the file. So I did not find a vulnerability in the TypeScript compiler itself. TypeScript is safe. Your Node modules folder is not protected from me tampering with it. That's what happened. But I spent those 2 nice evenings playing with it. And then, yeah, it quickly gets boring. It's a lot of fun. It's a rush when you do it, and then when it works, well, what else can I do? Attack some real people? That's not something that I like doing. I prefer fixing and helping people. So let's fix this. So I spent the next 2 weeks figuring out how to make fixing this reliable and fairly easy. And let's look into it. So what you need to do is run npm CI or yarn or pnpm with --ignore scripts flag. And that gives you security, because every package that wants to attack you with a post-install script will not get its post-install script run, because all of them are now disabled. We're done. Thank you. Yeah, is that all? Maybe. Almost. You might discover your app is no longer working. Is that a problem? That might be a problem. So post-install scripts don't exist just for the malicious people. There's a lot of regular usage that packages make of those scripts. So some of them are really necessary. Yeah, what now? So you need to run selected scripts, especially if you're building a Node.js application. You're going to have a bunch of dependencies that need to build their native add-ons. So they compile some C++ with some integrations into Node itself. So you need to rebuild them, and that's what you can do. So NPM has a command, npm rebuild, and you give it names of packages that you've identified that you need to run their install scripts. If that happens correctly, they will run again, and you're skipping all the packages that could have malicious intents because they didn't have a script and now they do have a script, right? There's a tool for that if you want yarn support and a bit more control over what's happening, etc. It's called allow scripts. It's part of the LavaMoat tool set, LavaMoat logo. There you go. That's authored by Kumavis, and I joined recently. So now I'm also working on LavaMoat a bit and a few other components that might in the future be added to LavaMoat, and it's a lot of fun. And I had this presentation going in its first version before I joined LavaMoat, so it's how I got there. So I joined the security team at MetaMask, and by the way, we're still looking for some people, and if you know what MetaMask is, and you're a developer watching a developer conference, you should check out Snaps. It's quite interesting, but not a topic of my presentation. So LavaMoat's toolchain gives you allow scripts which have a setup helper. You can run allow scripts setup. This is an actual bit of the documentation. And it's going to put ignore scripts in your RC file so that you don't have to type it out every time. It's still worth typing out in your CI pipelines code, by the way. But it also installs another tiny tool, which is called pre-install always fail. And if somehow your ignore scripts configuration is turned off accidentally, it's going to fail the installation before most scripts could even start running. This is a very nice safeguard in case your setup is broken. Okay, that's great. Now you only need to figure out which install scripts to run. You can take all of the install scripts that you're currently running and assume if I've been running them for 2 years, they're fine and I can still run them. Or you can narrow it down to the ones that are actually needed, because some of them, all they do is they attempt unsuccessfully to display a message that a project is looking for sponsorship or something. And in NPM, since version 7, these are no longer even visible. So you need to look through your packages and choose which post-install scripts you're going to use. And that's a lot of work. How do I know? I spent 2 weeks of my hobby time doing it. And now there's an app for that. So you can install it from NPM. It's called Can I Ignore Scripts? And once you already install like npm ci -- ignore scripts, you have your node modules folder. You can run this app and look what it finds. So it's going to tell you which packages are safe to ignore, and they're still going to work even though their post-install script didn't run. It tells you what to keep. And it's gonna also let you know that you need to check some of the packages if it doesn't know them yet. So I've did a bunch of research, put it all in a JSON file. There's stuff that you can keep, there's stuff that you can ignore, and there's a bunch of stuff that's in the to-do section, or if you find something new and you get a message to check it and you actually check it, please go back to the GitHub repository for Can I Ignore Scripts and do a tiny PR, just adding a line in data.json and saying why that's the case. So Can I Ignore Scripts is pulling that data from the public deployment of this repository online, and it's always up to date. You don't have to reinstall it every time. And it's shipping in case you want to deny it access to the internet. That's also fine. It's shipping with a copy of the data.json that was most recently published. Okay, moving on. So now you know not only that post-install scripts are dangerous, you also know that it's not trivial to defend from them. You have to set up a few things. Now you need to convince others. So a change to your pipeline might be something you just come in tomorrow, do commit, and get a bonus at work. Or maybe you're in an organization where you have no control over how your pipeline is operating and your CI scripting, etc. What do you do then? Well, you need to convince others. So there's probably this bearded hermit living somewhere in a cave who's the only person who actually understands how Jenkins works. And they're sitting there looking at orbs turn from blue to red all day. And you need to convince that person. So yeah, the best way to convince them is to turn another orb from blue to red. And I've got you covered, because I built a tiny tool that you can install as a dev dependency, and it's only going to run in CI. And it's going to break your build and print a big, scary message that this is dangerous. I'm a package that could have stolen your environment variables, and it's going to list the names of your CI environment variables that seem to contain some secrets. Okay, if that doesn't convince people looking at why the build failed, I don't know what would, but this could be helpful. Yeah, it's not doing anything bad. It's not hacking. Don't worry about it. I'm not hacking your CI. I'm giving you a tool to scare some people into understanding why this is important. Okay, now something more constructive. My recommendation on how to set up a successful pipeline for doing stuff with NPM. So step one, installation. You spin up a new container or a clean environment. Take only the package JSON, package lock, or yarn equivalent, and maybe your npm rc if you need that. Put it in the folder. Don't fetch the whole project, because maybe someone wants to steal your code, right? Then you run npm CI with ignore scripts or yarn again. Then you run allow scripts so that the selected scripts actually run. And you cache only the node modules folder. That's done. Everything else can be thrown away. Next step, if you're building something that has a build step, you take the node modules, you check out your application, a clean checkout of your application that didn't exist while you were installing the packages. You run your build, and you only save the result of the build. Okay, and everything else gets thrown away. Last, you need to publish. So you take the result of your build, you check out a clean copy of your application again for the package JSON, as you've seen before. A clean package JSON that didn't have a chance of being modified. And you npm publish or deploy your application with that. Okay. And if you watch the Lava Mode organization, I'm starting a project to build a reusable workflow for GitHub Actions that's actually going to do this and a lot more to deliver a secure cache of node modules without risking any form of attacks possible. Yeah. And you should be on the lookout for my next talk about hardening JavaScript coming this year. Thank you. I'm looking forward to your questions, and I'm going to be here to answer them. And then afterwards on Twitter, feel free to find me there. I'm going to announce my new talk and anything I produce in there as well. So if you're interested in using any of the tools or discussing them, that's where you can go. Thank you. Hi there.
Hi.
Hope you liked it.
It was amazing. How are you doing?
Doing good. A bit hyped, after all
hyped.
this.
I think we're also hyped. So, are you ready for some questions?
Yeah, bring it in.
So, the first question is, can a node module being installed affect my machine outside the project folder in which it lives?
Oh, yes, obviously, yes. So the post-install script, the main thing I demonstrated today, is simply running a command as if it was in your terminal. So a post-install script might as well pick a random JPEG, send it to your mom, and then format the drive.
Okay, so kind of the same precautions should be taken regardless of what you do. It's like
yeah. So it's preferable to use ignore scripts everywhere. And it's a trade-off, right? So you need to figure out which of those to run, and the whole presentation was about resolving that trade-off, actually, and then some hacking.
Okay, the next question is, aren't node packages just part of the story? In other words, how would it fit into full stack vulnerability scanning?
Yeah, so there's an important distinction between vulnerability scanning and preventing attacks and malicious activity. So vulnerability is something that happens to a good, benign package where someone made a mistake and someone malicious could use that mistake to break something. That's a vulnerability. And you're doing vulnerability scanning with like NPM audit or SNCC or a bunch of other things. You can also do static analysis of your code and your dependencies to figure out vulnerabilities that maybe no one found yet. That's SAST, and that was mentioned yesterday in the talk about unit testing for security being potentially better than SAST. Quite interesting. And there's defending from actual attacks, malicious people trying to do a supply chain security hack on your application, or to cast a wider net on many applications. And that means these are not known vulnerabilities, and you cannot really scan for them. I mentioned socket.dev. If you're adding or updating a dependency, you can look at it in socket.dev, and it shows you something that are worth exploring, looking into deciding if this looks safe to you. It's giving you warnings and stuff. So this is very useful for manually checking it. My focus most recently is on building defenses that would prevent a malicious package from attacking you and your application, even if you didn't really check if the package is secure or not. Just install it and push to CI. So that's what I'm focusing on here. And if you want full stack vulnerability scanning, prevention of errors, and overall app security, We can spend 3 days in training, and I can teach you all of it.
That would be quite a
That's
long
most
workshop.
of them. Yeah.
Okay, we have another question. With the steps you suggested, we're still not safe against scripts modifying fields after TypeScript run, or was that also using NPM script?
So the attack, or all of the attacks, was trying to show where examples where a post-install script would modify something else to circumvent the most obvious precautions you could take. And these examples were there to prove that you need to turn off scripts by default. So that was the scope. And it is possible for a package to contain malicious code in it. And there were attacks like that. Fewer than install scripts, but there were attacks where actually calling a function from a package would cause some nasty side effects. And in that case, none of these methods here apply. And you can either rely on other people finding this issue, reporting it, and then NPM audit or something else tells you that this package is bad for you, and you uninstall it, refuse installing it. But that means it's already too late because you were interested in the package. You probably installed the latest version, and then you get a notification after a few weeks that someone discovered this package had malicious changes made to it. So you can defend from that using some of the lava mode tooling I didn't mention here. And my next talk is actually going to be a deep dive into running any JavaScript from anyone without side effects of it maybe being malicious. So look out for that, or just explore the other stuff in lava mode repository without waiting for my explanations.
Okay, I think we have a really important question, so I just want to squeeze it in. If you can give a short answer to this one.
Okay.
A bit specific question. In your opinion, is there a way to prevent such attacks for a project that is dynamically installing packages during runtime?
Well, yes, it's theoretically possible. Tooling to do that already exists to some extent, but you would need to explore it a bit further and adapt to your use case. So look at lava mode and endo.js repositories. And if you can figure out how all that works, you're going to be able to apply it to your use case. And there's people doing that already. So MetaMask snaps that I already mentioned, and Agoric stuff. Agoric is another company in the field. And they're the authors of hardened JavaScript. Both of those are using hardened JavaScript to protect their environment in which the software runs from any bad outcomes from running someone else's code. So you can literally have a program that you let anyone paste any JavaScript into a field, and you run that JavaScript, and let's assume it's supposed to produce some results like a number or text, and you want that. But in case it also tries to attack your application, you don't want any consequences of it doing so. And that's already possible with compartments. Totally not the topic of this presentation, but the next one.
Yeah.
So follow me on Twitter. And the next presentation I'm going to give is going to be about that exactly.
Amazing. Oh, well, that's a big sneak peek. That's amazing. I want to say thank you for coming today. Thank you for both the talk and the amazing answers to the questions.
Sure. I'm going to look into the chat in a moment too, so I'm going to stay for a few more minutes if there's more questions, or just go to Twitter. @Nauter, and let's talk.
Of course. Amazing. Thank you. Have a nice day.
Thanks, everyone.